Hey everyone, welcome back to Cracking the GRE Math Subject Test, Calculus 1. This is problem number 33. So in this problem we're told that we have a region in the second quadrant bounded by two graphs, y equals ax squared and y equals bx, or negative bx actually, and that this region is revolved around the x-axis. So we get a solid of revolution, and then we're asked which values of A and B would make this volume, the volume of the solid, constant, regardless of what A and B are. Or what relationship between A and B would have to imply that the solid has a constant volume, regardless of A and B. So this is a pretty complicated problem. It helps to draw a picture and just have a little reminder of how to find the volume of a solid of revolution. So, first of all, let's draw a picture. Y equals negative bx. That's going to be just a line with slope negative b. It's going to look something like that. Okay, this is y equals negative bx. And y equals ax squared, that's a parabola. Let's draw something like that. Okay, and remember this is the second quadrant over here. So this is the area that we're interested in. These graphs are going to intersect at this point. What is this point? Well, that's the point where the graphs equal each other. Negative bx is equal to ax squared. The x's cancel out because, well, 0 is also one of those points. And we get x equals negative b over a. So this point corresponds to negative b over a. Okay, now, how do we find the volume of a solid of revolution? Well, I'll just remind you that there's something called the washer method. If you imagine rotating this around the x-axis, then if you look at it from the side, if you look at the result from the side, like from over here, you'll end up with a washer and this is the area where the solid is, and the area or the volume of the solid is going to be, well, if we just take one slice, okay, like one slice of this area, then the area of that slice, after we revolve it around the x-axis and look at it from where this arrow is pointing, is going to be the area of the big circle minus the area of the little circle. And the area of the big circle is going to be like pi, whatever the radius of the big circle is, r squared, minus pi times the area of the little circle, or the radius of the little circle. In our case, the big circle is actually negative bx, because that's the equation of that line. So this is going to be negative bx squared, and we're going to subtract from that the radius of the little circle, which is ax squared, because r is ax squared, and we have to square it. And then what we do is we integrate these little washers from negative b over a all the way to 0, and that gives us the volume of the solid of revolution. Okay, so let's do this integral over here. We've got the integral from negative b over a. You know what, let's just do the integral. We can factor out a pi, and we get the integral of negative bx squared. That's going to be b squared x cubed over 3 minus a squared. Now x squared squared, that's x to the 4th, so the integral is going to be x to the 5th over 5. And we're integrating this from negative b over a to 0. Okay, so let's plug in 0. 0 is just going to give us 0. And then we're subtracting pi times. If we plug in negative b over a, we'll get b squared. Now, negative b over a cubed is going to be negative b cubed over a cubed, and then we have that 3 there. And then if we subtract a squared, and then x to the 5th is going to be negative b to the 5th, all over a to the 5th, and we have that 5. Okay, so let's simplify this. This is going to give us, let's see, well, this a squared is going to cancel with a to the 5th, and we'll get a cubed. So we almost have a common denominator. Our common denominator is going to be 15a cubed, 3 times 5. And over here, let's just distribute this minus sign, so this will become a plus b cubed, and this will be a plus, that's going to be a negative. So we're going to have b squared times b cubed is b to the 5th, and we have to multiply that by 5 to get the common denominator. Plus, or actually it's going to be a minus here because of this minus sign. And we're going to have to multiply 3 times b to the 5th. Okay, and pi is out here also. Okay, so this is going to be pi. 5 minus 3 is 2. B to the 5th, all over 15 a cubed. So the only way that this is going to be a constant is if b to the 5th over a cubed is somehow a constant. And so this means that b to the 5th over a cubed is equal to some constant k. And the only way that could be is if answer C. B to the 5th is equal to 2a cubed. It could have been some other number, not just 2, like 4, 10, any number would work. But this is the only answer that has a relationship between b to the 5th and a cubed. So the answer is C.